Let's talk about what happens when you want to add an electrophile onto a benzene ring and there are two substituents on the ring already, and that they are directing the incoming electrophile in maybe the same position, maybe different positions, and let's talk about the competition between them. The bottom line here is that a strong activator has more influence over the position of the incoming electrophile than a weak activator, which has more influence than a weak deactivator, which has more influence than a strong deactivator. And so if there's a competition, then whichever one is higher up on the pecking order wins out, and that will direct the major product will be the one that is being directed by the one that has the greatest influence, or the greatest activating effect. So here are some ones to practice. Before we practice them, because I know I will forget, let me find the two problems in your textbook. On page 505, problems in chapter 16, problems 14 and 15 are the ones to do for practice after you get done with this. So do chapter 16, problems 14 and 15. That'll just give you more practice on what we're going to do right now. Okay, so the first example we have here is we have two groups, and the first thing we need to figure out is whether they're strong activators, weak deactivators, or strong deactivators. And then we have to figure out where they're directing the incoming electrophile. So the OH group here, strong activator, ortho-para director. The chlorine right here is a weak deactivator and also an ortho-para director. So we've set up the competition, and I usually don't use colored pens, but I'm just using that to help to illustrate my point here. The greatest influence of these two groups is going to be the strong activator. That'll have a greater influence than the weak deactivator will. And so what I'm going to show here is where this OH is directing, and I will draw a longer arrow if it is directing more strongly. So this is directing in the ortho positions, can't direct in the para position because there's already something there. Then the chlorine is a weak deactivator, not nearly as great an influence as the OH, and that's also an ortho-para director. It can't direct para because it's blocked, but it can direct ortho. So notice that I'm drawing a shorter arrow. So what I'm indicating here is the greatest influence in the incoming bromine here is going to be by the OH group, and it's going to be directed in these positions, which are equivalent to each other because there's a mirror plane in the molecule. So this isn't the only product that will form, but this is the major product that will form, where the greatest influence is in directing. So with the OH there, the chlorine here, and then we're adding the bromine. Doesn't matter if we show it on the top or the bottom, we're adding. That is the major product. Okay, so for each of the next ones you can pause the video. I'll give you time to pause the video and figure it out yourself, and then see how you did by comparing with what I've done. Okay, so we have the bromine here, which is a weak deactivator and a ortho-para director. And then we have the nitro group here, which is a strong deactivator and a meta-director. Okay, so which of these is going to have the greatest influence? The weak deactivator has more influence than the strong deactivator. So we're going to draw big arrows for the influence of the bromine, and the bromine is directing ortho-para, so it's directing here, it's directing here, and it's directing there. The nitro group is directing meta, already blocked there, and so I'm going to draw a short arrow showing the directing to the position that's meta to the nitro group. So again, the major products are going to be adding the sulfonic acid in this position, and this position, except that this is crowded. Whenever you have a position that's in between two other groups, then that will add much more slowly, and that will not be a major product. So let's draw then the two main products that are going to form from this reaction. Bromine here, nitro group here, and then the sulfonic acid will add in one of these upper positions, and that's one of them. And then the other major product will be adding to the other uncrowded position, which is right here. Okay? Again, go ahead and pause the video and work the next one. Then turn it back on. Sulfonic acid, strong deactivator meta-director, methoxy group, strong activator, ortho-para-director. So this one will have the greatest influence. It's directing ortho and para to itself. That ortho is blocked. This ortho is available. This para is available. And this sulfonic acid is directing in the two positions that are meta to it. And so it is directing, well, look, it's directing exactly in the same place. And so these are reinforcing each other. This is the best case scenario. You have, well, not quite the best because they're being directed in two different positions. But both groups are directing to the same position, and they're not competing against each other. So that is good, but we'll still, it's not the absolute best case scenario because we'll still get two products because they're directing in two positions. So here's our sulfonic acid here and our methoxy group here, and one place that the ketone will add will be para to the methoxy, and then let's add the other product here, sulfonic acid, methoxy, and then right next to the methoxy would be the other position that the ketone would add. So these two products would form, and they're both being directed to by reinforced by the two groups. So again, go ahead and pause the video and work the last problem and then start it up again. Strong activator, ortho-para director, strong deactivator, meta-director. Para position is blocked, so the amino group is directing here and here. Meta-director, oh, here's another case. Now this is the best case scenario because this nitro group is directing in the same place as the amino group is, and it is symmetrical, and so it doesn't matter if it adds here or here, you get the same product. So now we are getting only one product. It's not that this is the major product, we are getting only this, essentially only this. There could be, trace amounts of other products. So here is our nitro group, amino group, and we're adding a chlorine Doesn't matter, again, if we add it top or bottom, it's the same product. Okay, so that is how you sort out substituent effects that are competing with each other. And you can go ahead and test your ability. I'm sure you'll run into some on OWL as well, but the ones that are within the chapter in the textbook have answers in the back of the book, and so these two are within the chapter, and you can check the answers in the back of the book.